Now we are completely ready to do another problem. Let's talk about linear equations in two variables. Now try your best not to think about a delicious, juicy hamburger and about how wonderful it sounds, especially if you were to put melted cheese on it, crispy bacon, a toasted bun with these huge potato steak fries. So we're not going to think about that. We're going to talk about linear equations in two variables. If I gave you this example, x plus y equals 5. This is an equation that's in two variables. I've got x and y. Now we need to talk about what does this mean and what do solutions mean, because we talk about equations and we talk all the time about solving them. So what does it mean to be a solution? And for us, a solution is any ordered pair. It's any ordered pair that makes the equation true. Any ordered pair that makes the equation true. So if I look at x plus y equals 5, could you guys come up with an ordered pair that would be true for x plus y equals 5?
3 and 2.
The ordered pair 3, 2 works, right? Because if I replaced x with 3 and y with 2, doesn't that equal 5?
Mm-hmm.
Yeah. Is that the only thing that works? What else?
2 and 3. 4 and 1.
4 plus 1.
4 and 1. I heard 2 and 3 works. You said 4 and 1. Is that it?
0 and 5.
0, 5.
Negative 5 and 10.
What? We can talk about negative numbers? Holy cow. Speaking of cows, hamburgers. So negative 5, 10, this, we could even go crazy and say 1.732 and 3.268.
Quit.
You quit?
Yeah.
No, you don't quit. So these guys work, right? How many solutions do we have? Just 6? That's it? That's all? We haven't exhausted all possibilities, have we?
They can be indefinite, right?
There are an infinite number of solutions here. So since we cannot list an infinite number of solutions, we have to find a way for describing the solution set for this equation. And the way that we do that is by graphing. So you got your graph paper, and I've got my graph paper. Of course, my graph paper is awesome. I want to see what happens if I take these ordered pairs and I actually graph them, at least those that fit on here. Because unfortunately, negative 5, 10 does not fit. Let's see. I've got the ordered pair 3, 2 is right here. The ordered pair 2, 3 is right here. 4, 1. And I even have 0, 5. I'm not even going to worry about writing this decimal one here. I mean, clearly where he goes is no problem. Now, what do you think about these points that I have here? What do you think about them?
They have a pattern.
They have a pattern?
There are lines.
Yeah.
Maybe I could draw a line through them? They have a slope? Fancy. We're going to talk about the slope a little bit later, but right now we're just going to be connecting the dots. So let's connect these points, because it does appear to me that they would all fall in the same line. Now, when you draw lines or you do any kind of graphing, you go from edge to edge of your graphing window, and you put arrows at the end. If you don't, you'll lose points. Now, it looks like there's some other points that we go through, some that are kind of nice and easy to pick off, like maybe this one right here. It looks like I'm going through the ordered pair what? What's this guy?
7, negative 2.
7, negative 2. Does that work?
Sure.
No.
If I were to plug it back into my original equation, which of course is x plus y equals 5, if I replace the x with 7 and the y with -2, does that still equal 5? Yeah. So what we have here is a line, and we need to understand what the line represents. What does it mean? And this line represents all solutions to this equation. It represents all solutions to the equation, and the equation in question here is x plus y equals 5. This means that any point that we can identify on this line is a solution to the equation, which means that if I plug those coordinates in, it would work. Do you all agree? So the line is how we represent our solutions. Okay. Now, there are other ways we have for talking about graphing these and even coming up with the points. So that's what I want to look at here. Okay. One of the first things that we have is a t-table. Now with the t-table, what we do is that we just pick values for x, we plug them into the equation, and we find the y. I know some of you like to be really original with the x values you pick, and you'll do something like 1, 2, and 3. Like nobody ever thought of that, right? But here's the problem. When I start plugging these guys in, like if I plug in 1 in here for y, for x, if I plug in 1 for x, I have to solve for y, right? If I plug in 2 for x, I still have to solve for y by moving that over, right? Mm-hmm. We talked about formulas last week. And we talked about how important they were for us because it can allow us to take something like this, and I can solve this for y one time, and I never have to solve for y again. How do I get y by itself? I subtract x on the other side to make this negative x plus 5, right? So when I do that, I can just plug in values. If I plug in 1 here, I have negative times 1 plus 5. What is that? That's 4. If I plug in 2, that means negative times 2 plus 5 is what? I'm adding, right? So I get 3. If I plug in 3 here, so that's negative times 3 plus 5, and what does that equal? Are all of these points on my line? Yeah, the only one we didn't already have on the line before is 1, 4. You see that 1, 4 is right here. Do y'all agree with me on that?
I'm sorry, how'd you come up with
This?
negative x?
I just subtracted x on both sides of the equation to get the y by itself.
Oh, that's what was on. Okay, thank you.
Yeah. Now, so all of this stuff matches up with what we have. And I know some of you guys want to talk about slope, and we're going to talk about that in just a moment. And let me tell you another reason why we do want to solve for y. If you're to look on your graphing calculator, you have to have things solved for y so that we can graph. So let's look at that.